Hi everyone, welcome back. We're going to continue to talk about the California energy standards and how they are applied to your lighting designs. And our topic is the mandatory requirements for installed lighting power. So let's move to non-residential building types. This is everything else, right? Offices, schools, hospitals, anything else other than residential. Okay, they're a little bit more complicated, as you could imagine. And so, how is installed lighting power restricted or controlled for non-residential projects? It's controlled using lighting power allowances. All right, let's get a couple of definitions out of the way first. So LPA, or lighting power allowance, is going to be kind of the maximum power budget that a designer can spend on the lighting in a building. And it's measured in watts, right? The LPD is the lighting power density, and that is going to be a code required or a given number. It's based on what your building or your space is used for, right? And that LPD is going to be measured in watts per square foot. So when we calculate and when we talk about lighting power allowances for non-residential buildings, there are two methods to calculate them. One is called the building area method, and the other one is called the space by space method. Let's talk about the building area method first. This is a code required maximum lighting power density for the entire gross square footage of the building, and it's based on the building type, what it's used for. All right. The energy consumption of all the different fixtures, everything in the building, are added up, and then they're divided by the overall area of the building. So it turns out that if you do these calculations, the LPD, all right, the maximum for each building type is roughly equivalent to the LPD that would result if you did the space by space calculation. All right, roughly, they're supposed to come out roughly equal. Right? The building area method is easy to understand and easy to implement, especially if you have a building that's all one use. It's all an office, for example. But if you're just doing, for example, one room, a couple of rooms, or you have a number of different uses in a building, you should use the space by space method. In this method, the maximum lighting power density is a weighted average of all the individual areas, every room, every different area of a building, right? They're all considered individually, and therefore it's a little bit more complex. Not really, it's just a bunch of different areas added up, all right? The problem is that it can lead to some subjective decisions that can end up with higher total energy use. For example, you're looking at a particular room. Is it an electrical closet or is it a storage space? That's a little bit subjective, right? And so if designers always opt for the higher lighting power density space, you could end up with higher total building energy usage under the code. So let's try a practice problem. All right, we've got a particular office, and the lighting plan for this 200 square foot office proposes 10 luminaires rated at 50 watts each. All right, that's maximum. But you're the lighting designer, and you actually specify some 30-watt lamps for each luminaire. So what is the actual power that's being used in this office? And what's the actual lighting power density in this room? All right, I'm going to ask you to pause the video and see if you can come up with this yourself. I'll give you a hint. Doesn't matter what lamp you put in there. What matters is what that luminaire is rated for. All right. All right, did you give it a try? Let's see if we can do this together. So at a rated wattage, a power use of 50 watts, multiplied by 10 luminaires, the actual power used in this room is going to be 500 watts. All right. Then you would divide that by the area of the room, 200 square feet, and you'd get an actual lighting power density of 2.5 watts per square foot. How'd you do? The next step is to check, is this space code compliant? We have these numbers, but are we actually allowed to proceed with this design? First thing I want to do is find the California Building and Energy Codes. And we can find them here on the California Building Standards website. Click here. And we are currently in the 2019 version. What I'm looking for today, by the way, here's where you find the building code, but what I'm looking for today is the energy code, which is down here in part 6. So I'll click on that. Here we are in the 2019 California Energy Code, and I'm going to go ahead and navigate to the table that we want because I know where it is. All right. It is here in chapter 5. And then we're looking for table 140.6. Let's scroll down. What you see on the screen, table 140.6b, is for the building method, building area method, and you can see that it depends on the type of building, and then you can find the allowed lighting power density, the LPD. We're going to use the space by space method, so let's keep scrolling and find table 140.6-C. All right, this is for the space by space method, also known as the area category method. And if you scroll down, you can see that we have the different uses of the area and the allowed lighting power density, all right, LPD. Scrolling down, our use is an office, and we have less than, that's supposed to be a less than symbol, 250 square feet. Therefore, our LPD is 0.7. Let's come back to our practice problem. The allowed lighting power density for less than 250 square feet of office was 0.7 watts per square foot. We're going to multiply that by our 200 square feet, all right, and we have an allowed lighting powered allowance, all right, of 140 watts. Let's double check, does our design meet code? No. We're not even close. All right. The actual power used in our design was 500 watts. We're allowed 140 watts. We need to change our design. All right, everybody. So in this video, we just talked about the California energy standards and the mandatory requirements for installed lighting power. We talked about the residential requirements, and that was the JA8 high efficacy lighting. And we talked about the non-residential requirements. That would be the lighting power allowances, building area method, and space by space method. Thanks, everyone.